Bosal is a family-owned business. We were established more than 100 years ago. Bosal is globally present with 6 R&D centers and 15 production facilities. In Bosal Lummen, we are the main R&D center of the Bosal Group, and we focus on multiple products. So we develop exhaust after-treatment systems for the automotive OEMs and for commercial vehicles. We develop tow bars for automotive applications. And we develop high-temperature heat exchangers that are used in the range of 500 to 1000 degrees. And after this development cycle, we hand over the product to one of the Bosal production facilities where the product is manufactured in large quantities. I'm standing here next to a high-temperature heat exchanger that Bosal develops. We develop multiple units. This is one of the larger ones. It uses the waste heat in the exhaust gases to heat up the incoming air to the gas turbine, which increases the efficiency of the turbine with about 15%. For the product development of the heat exchangers, we build typically one-off prototypes or very small series of prototypes, and there the need for additive manufacturing is very high because it avoids tooling costs. It would reduce the lead time of the components significantly, hence the large advantage. The challenge is situated here inside, where the flow is entering and where we have a diffuser to guide the flow. In this case, the temperature is around 600 degrees, pressure is about 3 bar, and the medium are exhaust gases, so they're quite aggressive. So here on top of the heat exchanger, you see the component for which we have the challenge. This is a diffuser, which today is a cast part. This component is located inside this heat exchanger. You can see it here at this side, where it is positioned like this inside the unit. So it's all the different steps going from designing the product for which we already have a 3D model, but we still have some dimensional freedom, but also selecting the correct material, which we of course have some experience for the high temperature, but also selecting the correct or the suitable production process. The student will be working in an interesting environment. We'll see the different aspects going from virtual design, physical design, prototype building. So we have the simulation software and knowledge to simulate the functionality and the durability. We have the 3D CAD design, we have the prototyping facilities, we have the test facilities to validate it. And I think that is key to also support the student in bringing this project to a good end. This heat exchanger we have been discussing is for a micro gas turbine application, but many of our heat exchangers are used for fuel cell applications and electrolyzers, so we are definitely contributing to the energy transition, moving to hydrogen. And next to this energy transition, it's also a link to more efficient cost control and lead time control to really use additive manufacturing in an actual development environment. Are you interested in making the energy transition happening with additive manufacturing and do that in extreme conditions? Then select Bosal as your additive manufacturing challenge. We're happy to work with you.